Today we're going to be talking about the distance between two integers, and these are our guided notes. As you may recall from our work with absolute value, distance is always expressed as a positive number, and it is written like this. If we see a bar with a number inside, we read it as the absolute value of 3, and that means that 3, positive 3, is 3 units away from 0. So it's a distance of 3 away from 0. If we put those same bars but put negative 3, we'd read it as the absolute value of negative 3. But negative 3 is also just 3 units away from 0. So we don't care what direction it goes in. Let's explore the distance between two integers on the number line. First, plot the following integers on the lines below. So if you recall, when they ask us to plot, we put a point or a dot right on the number line above the number that they give us. And I'm also going to plot positive 2. They're now asking me to find the distance between negative 7 and 2. So if I count from negative 7, it's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9 until I get to 2. So that was a count of 9. And what I did is I went forward or to the right, so I'm showing a positive 9. The absolute value of positive 9 is 9. So now let's try that if I started at 2 but went to negative 7. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But that time I went to the left 9. So that would be expressed as a negative 9, but that also equals 9. So the distance, no matter which way we move, is always expressed as a positive number. So this is 9 units, or a distance of 9. So let's start this again. Let's see what we can do. We're going to plot negative 4 and negative 9. So I'm going to plot negative 4 and negative 9. And they want us to find the distance between the two. Once again, if I start at negative 9 and count to 4, I'm counting 5 units. But if I start at negative 4 and go back to negative 9, I'm still counting 9 units. I'm just going in a different direction. But when we talk about distance, we only care about the positive value. So this is 5 units away from each other. So please try C for me, and then restart this video to check your answer. The answer is 13, because whether we went to the left or whether we went to the right, the distance between those two numbers is 13. Please pause this video and do letter D on your own. If you said 5, you are correct. No matter which direction we went in, it is 0 and 5 are 5 units apart. Now let's explore another way to find this. Turn to the next page. What if we were asked to find the distance between negative 5/8 and 1/8, or between 22 and 8/10 and negative 10 and 6/10? Would the number line be very efficient? Well, fortunately, there's a formula that can help us without the line. And here's the formula. Now, if you haven't dealt with a formula, and I believe you have in the past, it is made up of variables. So for instance, this is a very famous formula. Can you tell me what this formula means? This is the area of a rectangle formula. So the A stands for area. That means how many square units are inside. The L stands for length, and the W stands for width. And in math, when we put numbers side by side, it means that we're multiplying them. So we would use this formula if we knew what the length was and what the width was. We'd be able to find out the total area. Or if we knew the area and we knew the length, we'd be able to find out the width. So we're going to use a different formula today, and honestly, I'm not quite sure why they chose P and Q as their variables, but that is the formula they've given us. You're also going to notice these bars, which means once we find the difference between P and Q, which we'll replace with numbers, we have to find the absolute value, meaning that our answer is going to be positive. Using the formula, let's explore why it doesn't matter which number we substitute for P and which number we substitute for Q. So I'm going to first write down this lovely looking formula. It starts with the absolute value bar of P minus Q. And just like we learned the other day when we're evaluating expressions, I'm going to go ahead and substitute 7 for P, -7, and +2 for Q. So I still have to keep these absolute value bars, but I'm going to replace P with -7. This minus sign is part of the formula, and I'm going to replace Q with the number 2. So now, kind of like a set of parentheses, we're going to do what's inside the parentheses first. So that means I'm going to go ahead and try to work with just numbers inside, and I'm going to ignore those absolute value bars right now. I see a minus, so I want to do a keep, change, and change. And I have to remember those bars are still there. I'm just ignoring them. Oh, I see 2 same sign numbers that are being added. Should I add them or subtract them? If you said add, you are correct. We add same sign numbers and we keep the sign. So this should be -9, but those bars are still there. So this is now the absolute value of -9, and absolute value is always positive. So our final answer is +9. So now let's try this again. We're just going to use the numbers in reverse. So this time we're going to use 2 as P, and we're going to use -7 as Q. Same numbers, just different order. So we're going to start with our very lovely formula, the absolute value of P minus Q. And I'll put a curly on that so it doesn't look like a 9. And now I'm going to substitute. We have assigned 2 for the letter P, so we're going to replace P with the number 2. Minus is part of the formula, and Q is -7. So I'm going to go ahead and put that -7 inside parentheses so I don't confuse it with a minus sign, and then I put my absolute value bars back on. All right, this definitely calls for a keep, change, change. I'm going to keep that absolute value bar there. I want 2. I'm going to change this to plus, so I'm keeping the 2, changing the minus to a plus, and making the 7 its opposite. So keep, change, change. Absolute value bar. And now they're both the same sign numbers. So what do I do with same sign numbers? If you said add them, you're correct. I'm going to add them and keep the sign. But I have the absolute value bar. So what's the absolute value of +9? And no matter whether it's positive or negative inside those bars, the final answer when we release the absolute value bars is positive always. So please answer the follow-up questions, and that will serve as our exit ticket as well. Thank you for listening, and we'll complete the second half of this lesson tomorrow.